This study deals with abrasive and impact resistance of multiphase quenched steels. A comparison of the wear resistance between two multiphase steels and the largely used hot-fill fully austenitic steel is investigated by means of 3 different laboratory wear tests. Those tests have been selected for their complementarity in the involved wear modes. Here we can see a G65 test, which involved mainly sliding wear. The second test, a modified LCPC test, induces a combination of impact and wear abrasion. And the third test is a ball mill impact machine, where the abrasion is obtained by heavy impact of metal balls falling on the samples in a rotating tumbler. The cross-section foliation hardness was measured after the modified LCPC test. By comparison with multiphase steels, the hot-fill sample provides a greater surface strain hardening, up to 300 vickers. When the energy impact is much higher, 6 joules in the case of the ball mill impact machine, the work hardening is also much more, as we can see here. The multiphase grades work harden up to 100 vickers under the worn skin, whereas the maximum hardness increase of plus 420 vickers is obtained for the manganese steel. Both of the multiphase steels, composed of martensite, bainite and retained austenite, were analyzed by X-ray diffraction. These analyses revealed the drop of the retained austenite to 0% after the impact ball mill test, suggesting a trip effect occurred during the heavy impact test. About the hot-fill grade, this is rather a twin effect which occurred during the test and explaining the great work hardening. Thank you.